I'm Rosanna Hu, Chair of the Architecture Department. And before I introduce our speaker tonight, a very special Cunningham Lecture, that is, I want to acknowledge the land on which we gather. We acknowledge that the University of Pennsylvania is situated upon the ancestral homeland and territory of the Lenape peoples. As members of an educational community, we are obligated to know the histories of dispossession that have allowed the University of Pennsylvania to grow and thrive on this vibrant terrain. As designers and thinkers, we endeavor to build in ways that lead towards justice, and we are committed to working to dismantle the ongoing consequences of settler colonialization. Tonight, it is my great pleasure to welcome Lucas ter Hall of Studio Rap, who is joining us from the Netherlands for this year's Cunningham Lecture. The lecture series was established in 2013 to support the Warren W. Cunningham Annual Lecture Series in honor of Warren W. Barney Cunningham, a founding member of the Philadelphia architecture firm Gettys, Bircher, Qualls, and Cunningham. Barney, as he was known to many, was born here in Philadelphia and received his bachelor degree in architecture right here at Penn. In addition to his leadership and his firm's many contributions in design here in Philadelphia with iconic projects like Philadelphia Police Administration Building, Franklin Institute's Future Center, and the Moore Building, on the other side of 34th Street, Barney was a mentor to a generation of architects through his studios here at Penn. Many of these alumni came together to establish his lecture series in his spirit, charging us to advance our thinking and practice of architecture beyond tradition, beyond the norm. I will invite Andrew to come up here and speak in detail about how Studio Rap embodies that vision. But first, I want to acknowledge the wonderful friends of Cunningham Lecture who are here with us this evening. Chris Capaldi, Mike Keene, and Dan Russoniello, along with Rosemary Fabian and Tom Normelli. I probably got that wrong, sorry. Yeah. I would also like to thank Turner Construction for their generous sponsorship of the 3-day robotics laboratory or workshop, and for providing the opportunity for students who have not been exposed to robotics before. And I think we just saw in the review earlier, the work has been really amazing. We want to welcome Jim McNamara, the Manager of Business Development at Turner Construction Company, for joining us tonight. So now I want to give the mic to Andrew.
Thank you, Rosanna. My name is Andrew Saunders. I'm the Associate Chair, Department of Architecture, also the Director of the MArch, and I teach in the MSD RAS program. So I'm super excited tonight to introduce Lucas ter Hall of Studio Rap, who will be lecturing with us. It's been a real pleasure hanging out with him for the last 3 days. He flew in on Sunday and offered a workshop, which was 2.5 days. And anybody that's worked with robots knows that you can't do anything in 2.5 days with robots. But incredible what the students were able to learn and produce in the kind of spirit of teamwork that was able to happen in the lab. That was, thanks to Lucas' leadership, but also thanks to the sponsorship of Turner. We were able to do that, not only bring Lucas over, but to outfit the lab to allow more people to participate. So we had our RAS students, but we also had a mix from all other programs, AAD, MArch, all 3 years participating. So it was really nice to see all of the work today. So anybody that missed it, all of that work that has taken place is on exhibit in the upper gallery. I also want to thank Robert Stewart Smith, who is the director of the MSD RAS program, for helping me coordinate this and helping facilitate the lab and allowing his class to participate for a week. You guys have a midterm tomorrow, right? A Friday. So hopefully it's not too stressful, and but I think it's a really great opportunity for the students. I want to thank also Masalagu, who coordinated with Lucas and set up everything, established the workshop and concepts, and was able to be the counterpoint over here while he was in Netherlands coordinating. Thank you, Masa. Excellent job. And then Nicholas Sideropoulos and Shunta Moriuchi, who helped assist as lab operators to put everything together. So I just wanted to thank, there was a large team and a lot of participants, and it all went really well. So thank you very much. So tonight, Lucas will present Studio Wrap, Digital Craftsmanship in Architecture. This lecture will explore Studio Wrap's revolutionary approach to architecture, where computational design meets digital fabrication, and how the firm seamlessly integrates algorithms and advanced manufacturing, crafting spaces that redefine the boundaries of creativity and functionality. Lucas ter Hall is co-founder of Studio Wrap, an award-winning architecture, design, and fabrication firm based in Rotterdam, Netherlands. Lucas ter Hall graduated with distinction in 2014 with a Master's of Science in Architecture, Urbanism, and Building Sciences from the Technical University Delft, specializing in robotics in architecture. Alongside co-founder Wessel van Bellendonk, they are dedicated to bringing innovation in architecture through emerging digital technologies aimed to inspire people worldwide. Since the establishment of Studio Wrap, Lucas and Wessel have led various projects, including New Delft Blue, Ceramic House, and The Float. Hopefully we'll get to see all those tonight and more. The studio's mission is to enrich the world with a new architectural language, breaking barriers and making the world more exciting and diverse. With that, I will introduce Lucas. Come on up.
Switch to my presentation. Okay, first of all, Andrew, thank you so much for inviting me. I always love to visit United States. Super nice to be here. Also, the workshop was amazing. So thank you, Masa, Nick, and Shunta, who did basically all the work. So it's super nice, and especially the students with great results. Also, thank you, Turner, for making this possible. So my practice is together with Wessel van Berendonk, my business partner. We started this with the idea to combine digital, like computational design, with digital fabrication techniques. We both graduated from the TU Delft. And we learned these amazing technologies, but there was quite a gap between what we learned in university and real life practice. So there are like a few other companies that where we could work, but we decided to start our own company in Rotterdam. So here on the left you see our team figuring out geometries and designing it. And on the right side, we have a nice playground in Rotterdam with multiple robots where we can experiment different building techniques. This is, I'm telling the story of Studio Wrap through these projects. Level 1 is top left is our first project, and those are the two that we delivered last year, and it's mainly ceramic printing. And I go a bit more into depth with these two projects. So this is our first project. It's made out of mezza wood. It's like layered timber panels. And it was we got a great opportunity of the Port of Rotterdam to create this indoor office. And we just decided to design it and to build it for 50,000 euros. It was nothing, but we were just out of university, and we thought we could do it for that price. I think only the sprinkler installation was like 15,000 euros, so we totally underestimated the cost. But we milled out all these panels ourselves. We rented a robot, and it took us, I think, 2 weeks designing, 2 weeks fabricating, and 2 weeks of assembly. And therefore, we could keep the cost down and realize this project. And it was a perfect kickstart for our office, because it was published on the Zine, international recognized website. And with this project, we could launch our company. About the project, we were quite intrigued by with the Rhino Volt plugin in Rhino. So we used this plugin to design the dome. And we also made these screw connections it was basically not needed, the screws, because it's all compression, but it was easier to assembling it. And we worked, I think, from 7 in the morning to 1 a.m. or in the night to get this project done. The second project was a balustrade for a Dutch bank, ABN AMRO, and we decided to reuse their waste material of the main structure. It was built with wood. The pavilion was called Circle, so everything should be like reused. We decided to make this robot setup that was cutting those battens in all unique pieces with holes in it to put dowels in it and then post-tensioning everything together. So in a later stage we could disassembling it again. So it was no glue was used. But I think this took us a year to develop it. So we developed this whole robot setup. We bought the grippers on eBay. And with this process, we could create these pre-assembled panels in 1 day. So it took us 1 day to create like this element. And it has to be fireproof, so we coated a lot. And it was like, they put like salt in it to make it to make it more fire resistance. And after 1 year of making this setup and experimenting, we decided basically to throw everything away, because it was not really people were not, they didn't want those elements again. It was like for one project, and so we never reused it. So that was a bit unfortunate. And then we were rethinking our business strategy. So first we were a bit naive, and we thought like, okay, for every client we will think a new fabrication method and design a new project. But nobody's paying 1 year of research to get this done. Also, the bank didn't pay for it, but we were just too fanatic to work on it and to make it happen. This was built, but we never got any other projects out of it. Although we learned a lot. So we learned, these are, for example, 10,000 unique battens. So we learned how to program the robot in a certain way that the robot can do repetitive tasks, but with different and unique elements. So yeah, we learned a lot of this, and we also learned that we shouldn't do like all different kind of projects. So basically, we have these projects that are more focused on triangular shapes. It can be in metal or wood. And later we also focused on ceramic printing. This was a project for example, the triangle shapes in metal. This was an opportunity, like we knew the client of this theater, and he had a budget problem for an interior. And we told them that with that budget that they have, we could create something really unique and exciting within the budget. And I think this project was done in 5 months. So from start the talking to delivery. And we collaborated with Arab on this project. So we developed this this mesh that we could influence the triangulation, the roughness of that mesh, and we gave those parameters to Arab, and then they sent us the informed model, or they did iteration, how the model can be shaped in such a way it should be acoustically optimized for that space. And we had a nice relation with a factory in Rotterdam that were producing these metal elements. Although they didn't believe it could happen, because they were making quite standard aluminium sheets or metal sheets. So they trusted us only if we could send our code to their machine. So at the end, we were producing all the code for those machines. And together with a mock-up, we could also convince the client that this combination of this fabrication company, Studio Hub, and Arab could work. Yeah, this is the concept. One of the nice parts of this project was that the production was already started. So the prefabricated elements were already placed, but we noticed that the exit sign was not integrated well. But because we were in control of the production, we could, in the later stage, just change it. So we pushed it in slightly to have it integrated better. But that's something, I think it's one of the powers of that you're in control of the whole production process, that you can change things in the later stage. All our projects, we have to make mock-ups to convince the clients that it is possible. Also with this one, we spend a lot of time to make, to think about how we're going to make it. And then we express it in the mock-up and then in the final design. So we thought about this project, and then we start thinking about, okay, let's reuse all these things that we learned of this project. So we did a small project outside, in the same neighborhood. It's like a sound barrier for the apartments above. And we could just reuse the scripts, change it a bit, and with the same company produce this sound barrier. And now we're making ceilings for a school in Rotterdam. So you see these pockets in the buildings. They will all be clad with a ceiling that we designed. And it will be part of their curriculum of the students, part of their program, so they can actually program the roof. It's, how you say, the school is about media design. So that's also a way how we could get extra budget, because it was part of the program. So then at the end they could play Tetris or Snake on the ceiling of the school. And then also during the night you can showcase their work from the outside. So we thought, like, okay, when students walk by, they can show at their parents what they programmed on the ceiling. They could hack the school. This is currently, this is again like a mock-up to convince the client how we're going to integrate the lights, the smoking detectors, the sprinklers, etc., to combine everything in a ceiling. This was done in 2022, I think. The client came to us and they wanted to have the most sustainable home of the Netherlands. And with this project, we combined CLT, cross-laminated timber, and cork, just those two materials. So no plastic sheets or anything, to create this, this floating home. We made it in a corrugated way, or like, I'm not sure how you say it, like a jagged structure to reduce the CLT, so to create stiffness by the shape itself, to reduce the material. Here you can see it. And we won actually the most sustainable, no, the floating home of the Netherlands award or something. Yeah, and they are really happy. Yeah, we milled out the foam, the cork pieces. So they're like two layers of cork, one in the middle, or one closest to the CLT. It's less dense, so it's more better insulating properties. And on the right, it's more dense, so it's stronger. So some pictures. We created some reveals. We milled out. Everything is CLT from the inside. We really like to work with CLT because you can integrate. It's a nice material to have this design to fabrication, because everything is milled out and cut it with nice machines. We collaborated with a company in Austria to get those CLT panels delivered on site. It's actually built in one day, so that was also great. It's in the city center of Leiden in the Netherlands. So the neighbors were also happy with that. And yeah, we could integrate nicely the window frames and everything. Here you can see some of the ceiling. So it's like this jagged shape. In the Netherlands, you see a lot of floating houses on the canals. We try to scale up this this technique of CLT combined with cork. Didn't happen yet. We did 2 competitions. Unfortunately we lost. Although we have like the municipality of Hilversum, it's a Dutch city. They asked us to design one parking lot for bicycles, and this bus stop. This will be built next year. So we got approval from the municipality. So this will be built. So it's a nice continuation of the CLT triangulated projects that we do. This is our first project with the with the ceramic panels. Basically, it was, I think, 2018 when we talked with the client. They asked us to design something for 2 gates of an apartment building in the Netherlands. This apartment building, this block, had a courtyard inside, connecting, or the 2 gates. You could enter that courtyard with 2 gates. It is public, but they wanted to have something special. So we proposed them a gate made out of brick, like robotic brick stacking. It was quite popular a while ago. So we proposed that, and metal sheet bending or pinching, and ceramic printing. This is still in the phase that we wanted to experiment with a lot of techniques. So we proposed that. They chose for ceramic printing. And we sold this project with the idea to print everything, but we didn't have the technology yet. So we had to develop the whole technology. We're quite naive with that. But we thought, like, yeah, a lot of universities are printing with clay. So we thought it is possible. So first we were trying to buy clay printing machines, but they were quite slow, and we made this calculation that we have to print a tile within 15 minutes, otherwise it was not feasible. It took like too long to print it out, because there are like 3,000 elements. So you can imagine if one element takes 1.5 hours, it takes like years to print it out. So yeah, then we had to develop our own material, machine and way to print those panels out. We totally underestimated that process. Like we didn't. Nobody of our team touched clay. Like it was super challenging, and we spent 2 years, I think, like 2 years with trying to print, and then we came the next day after all the panels were delaminated, or was quite a struggle to get everything right. Fortunately for us, there was this crisis in the Netherlands, that there was too much, I forgot the name, like nitrogen or something in the air. So there was not possible to build anymore in the Netherlands. So that project was on hold. So in the meantime, we could continue developing our printing process. With the ceramic projects, we always try to tell a story. So we have on the left side, it's also how we sold the project. Like in Delft is known for the porcelain plates. And you have this decorative frame around those plates, and the idyllic scene in the middle. And we thought this is a perfect metaphor for our gates. So you see the blue tiles are the decorative frame, and in the middle there's this idyllic scene from the courtyard inside the building. And with every project we try to tell a story with this ceramic panels. And this is the result. We work together with Tichelaar, Royal Tichelaar. They are one of the oldest companies in the Netherlands. They are 450 years old. And it's really nice to work with them. They are really analog, so they do everything by hand. And yeah, we are the opposite. We would like to automate everything, and it's a nice combination. This is how we made the design. So it's based on this pattern inspired by nature, and then we combine the bumpiness of the clay together with the way of glazing. So it created these valleys and hills to emphasize the 3D-ness of the panel. This is our experimental experiment robot. So this is in Rotterdam, where we could change the extruder or change easily the clay settings. And this is in the factory of Tichelaar. So we developed 2 robots and we placed those 2 robots in their factory. And people from Studio Rap, they can work there normal hours, so like 8 hours a day, together with those robots. And we can produce 40 of those tiles a day. Although like just producing those tiles, there's a lot of things that we have to take into account. Like these are all unique, so we had to like stamp it with a certain number and place them in the right order. So there was a lot of things that we had to deal with. But so this project took us, I think, 5 or 4 years, and the next project it was 1 year, and now we're doing a project that takes half a year from design to finish. So it goes faster with each project. This is like the corner tile, so that we try to experiment with certain infill strategies. So here it's more like also sometimes the corner tile is too heavy, so we have to optimize the infill strategies to use less clay, although on the right element, for example, is way stronger than the left one. So we create this family of panels to create a certain design, and all these parameters are like within a certain range. So we are confident that it can be produced. This setup can produce 3,000 unique panels in this certain design range. This is a video. It's quite quite a normal building block, but then we put these two gates inside that building block, and it gets a lot of attention, and it's really nice that it's public, so everyone can visit it. Although now they are thinking about to put fences in front of it, but that's hopefully it will not happen. But so this is the design. I really like the panels that are a bit weird. So you get this clash of 2 types of patterns creating shapes that you will not think of or you will not design. So these spontaneous effects of this algorithm. I think these are really, we're always trying to find interesting elements that are unexpected or like not designed. Where you can. Some more pictures of it. It was our first project, so there's still a lot to improve. But yeah. So it's quite subtle, but still popping out. Like if you look closely. Then we think the previous project was not delivered yet. We had to start the printing of that project, but we convinced the developer to do this project in Amsterdam. and it's a storefront of a high-end shopping brand. But this is it's the PC Hoofdstraat in Amsterdam, and it's part of this. It's like the Fifth Avenue of Amsterdam, and there are a lot of interesting designs. So in the street is also, for example, the crystal houses of M4DV, and some stores of made up from UN Studio. So we're super lucky that this developer gave us an opportunity to develop this with carte blanche, so we could do everything what we wanted. So we increased the resolution a lot of the printing. So again, we're trying to tell a story. This the concept of this facade is inspired by cloth, because there will be a fashion brand in it. So we have this multi-layered concept. We use the creases to generate a bit the main shape, and then we have this these yarns, these interlooping yarns, and the stitch pattern on top of these panels. Also, we had to convince the municipality of Amsterdam to get this project realized. So we, in the front view, you don't see it's that there's not much happening, because we use the same brick pattern as a traditional one. So it's quite subtle in the front, but on the side it pops out and it creates a 3D. And it's like flush on the top and more expressive on the side. That was also one of the conditions to build there, that the top area of the building should be quite subtle, and lower could be more extreme. So we got inspired by the stitch pattern on the left. This is like input for the machine to create the pattern on the right. When we try to mimic this with our clay printing process to create this language of tiles for this project. And we did a lot of iterations of the high quality of the sticking out of these pearls. We call it pearls, and then the glazing. So yeah, we had to go maybe a bit more extreme to get the right result, because it's fading away everything with the glaze. So I really like the left panel, but at the end it has to be glazed, but to get the really more like luxurious effect. So not only like a surface, but we also created some tiles for in between the columns, the reveals. We did a lot of testing and mock-ups to convince the client. Like how the seams will match. We noticed that clay warps a lot. We didn't know. Yeah, we didn't knew that. So we had to experiment a lot and to get the panels as straight as possible. This is our one of the guys that are printing like daily, and they are drying for 2 weeks, and then they go into the kiln, and then we glaze them, and then again in the kiln. The previous project was just 2 weeks drying and then immediately glazed and fired. With this project, we could actually buy 2 robots. So we sold that project, and then we could buy these 2 robots that could also print the other project, the New Delft Blue project. And after the printing a New Delft Blue project, we could print out the ceramic house project. And these are meant to use daily, and so the operator he was actually selling fireworks before his job, and we reschooled him to work for us and to handle those robots. So we made this cell, and with all the safety included, and this extruder where the cartridge could be placed in it, and you could press some buttons, and we sent the code from Rotterdam to Makkum. It's a place in the north of Netherlands. It's like 2-hour drive. It's like all the way to the end of the Netherlands, by the way, so it's a small country. But we could send the code to the robots, and then he could print it out, so we don't have to be there that often. So here you can see the two robots working. This is like these panels took 30 minutes to print, and the New Delft Blue project was 12 minutes, around 12 minutes. But these are quite big, although all the panels are around the 10 kilos. I think there's a video also of the spraying process, the glazing. So that's all done by Tegelaar, and it's all manual. These are the kilns. The brickwork is placed in stainless steel laser cutted cassettes. So it fits nicely. The plinth on the first floor, the ground level, it's glued. The panels are just glued to the rear structure. This is the result. So you can see also in a drawing, in the front view, you don't see that much difference with the building on the right. So we explained them that it's quite a subtle building. And when you walk there, it's also not that screaming or getting attention. But when you look up closely, you see the ceramic panels and you really want to touch it. Also the door handle, we made it in ceramics, so people can also feel it when they are entering the building. Those pictures. It was not the most, it's not the cheapest facade. Also the, also the stainless steel cassettes were quite, was quite a intensive job. Some more pictures. And with this project, we could get more attention worldwide. And now we're also doing other projects in different countries. So it was a really nice opportunity to showcase the possibilities of 3D printing. These are the laser cutted cassettes. It was a nice replacement for the mortar in between regular bricks. Because it's almost not possible to use mortar with these bricks. We 3D scanned the whole site, so we could align it nicely with the neighbored bricks, the bricks of the buildings next to it. This is a movie that we made. And the client was quite strict. So after building this, there were some panels that were too deformed. So we had to go there and replace them. And because of it's glued, we just used like a abrasive wire a lot behind it, and then we could quite easily dismantle the element and then replace it with new tiles. Not the best way, but was possible. This is like our second project, and I think the next project will be delivered this summer, and we're looking forward to experiment more with ceramics, and we think it's a really nice material to explore and to showcase this computational design possibilities. That was my presentation. If you want to follow us on Instagram, we showcase more of our work behind the scenes on mostly on our Instagram channel. So yeah, it'd be nice. Thank you. Sorry? Okay. Yeah. Oh yeah, of course. Yes. If you have any questions about my work, please.
Yeah, I think we can take maybe 3 questions.
How large are the panels of the cassettes?
Yeah. So these cassettes.
Yeah.
How
large is each unit?
Yeah. So we first built all these cassettes. So they are not exactly sure. They could be like 1 square meter or maybe even more. Then we place them on the existing facade, and then at the end we place the bricks. So I'm not sure if they were just elements of the. So maybe like here near this side, there are like 2 elements on top of each other, and then at the end we could place the bricks inside those elements. I think they were here.
Any other questions?
These ones.
I actually have one. I'm just curious. So, as an exterior facade, and since you said you're not using any grout, so for waterproofing, did you have to waterproof the inside layer first?
Yeah.
So this entire aperture is not waterproofing.
No, it's like replacing a brick facade, but behind it there's like plastic to block the water. Yeah, and we had to do tests. Like we did a lot of tests also about frosting, defrosting. So it would withstand winter times, and we frost and defrosting like 150 times in special chambers to test if the panels were strong enough, and also we hit it with sandbags to get the right strength of the panels. Actually, in Newdale's Blue project, the lower row of the panels were printed with extra infill to make those stronger in case people are bumping with their bicycle or they want to destroy it or something. Yeah. Yes.
Thank you very much for the fascinating presentation and sharing this with us. I have a question for you because you're working with lots of parts in different projects and different designs. What is your construction tolerance with respect to the scale of units and also material? If you can give us some ideas.
You mean like the margins of the seams and everything? Yeah, good question. Like I think especially with this project, you can clearly see the gaps between the panels. I mean, we're quite confident in the height of the panels. So that is just, we scan the surroundings and I think it's like millimeters accurate. But the hanging, it's quite fixed. So the seams in the width of the panel. So here we rotated the panel, so the width is that's quite challenging of the warping. So we need to make sure that there was enough space between the panels that they could fit, because sometimes maybe they don't shrink that much and they become too large that it will be placed inside. But for the new, and also the developer is quite conservative contractor / developer, and he wanted to make it possible to unscrew the panel, so there was space between the panels to unscrew the panel. But for the new project, we're just stacking them on top of each other, and I think our margin is like 2 millimeters accurate. Yeah.
And the shrinkage rates of ceramic, how much is that? The percentage, do you know?
I think around 10%.
10% shrinkage.
Yeah.
Thank you. It's fascinating.
Yeah.
Sorry, I have a question. Regarding the ceramic robot extrusions, did you guys at all change the mixture of what went into the ceramics? I just imagine like the extruder head and just, I don't know, the way the material dries. I don't know, just curious if it's like the same sort of recipe that you would use for traditional terracotta, or is it, for ceramic, sorry, or is it another one that you had to sort of play around with the recipe to get it right so that it could actually extrude?
Yeah. No, yeah, the clay, there's a special mixture. Yeah. So we use like a certain percentage of grog to make the panel strong enough, but with a like a certain pK value to make it sticky enough. So that's a special mixture, but also like last week we're trying to produce 40 panels. Sometimes we cannot manage to print anything. Like they all delaminate. We don't know why. Like maybe the clay was standing outside too long or inside. It all influences the clay. It's such a it's not really a nice material to work with. It's and then we're struggling. Like, why is the clay not behaving as we want? Sometimes we have like days that we cannot. We're looking for the problem. So maybe the problem was in the canisters. They're like a bit bended, so they couldn't go through it. Or we have a lot of these problems that we try to figure out. So it's quite because we made this planning that we can deliver this project in 1 month. And then like we start printing in the first 2 days, no panels were printed. So then when we contact the clay company, like did you guys did the right mixture? Or it's quite stressful sometimes. Yeah. Yeah.
Okay, if we don't have any more questions, I want to thank Lucas again and also Cunningham for this lecture series, very, very special, and also for Turner Construction for giving us the last 3 days of workshop. Thank you.